All right, now that we've determined independence with Venn diagrams and things like that, we are going to now be proving independence with a table. Now, it's a slightly different and it's a bit easier, in my opinion, to do it this way. Events are independent if, events are independent if you have a table, if the conditional probabilities are in proportion. So remember, the conditional probabilities is your given probabilities, or the one that says like probability of A given B, that looks like that with the straight up and down line, if they're in proportion. So you have to do an entire row or an entire column based on this. So what that means is the first one, so notice this says 1, 1, 1, 1, or up, Roman numeral 1, it has to be, that's the thing that needs to be the same. So the first element in the conditional probability, this must be the same, and you must do it for the entire row or the entire column. So this is 1, so we have to do it for A, B, C, and D. You just can't do it for A and B. You have to do it for the whole thing. Okay? So the way that we do the conditional, remember, it just changes the bottom number. So the bottom number isn't 720 for all of these. The bottom number is whatever A, B, C, and D are. So the probability of I given A, it would be 36. Remember the and over the total. So it's the total of A. So this one is B, 72 over 44. And then it's 144 over 288. And then it's 108 over 216. Are these the same? Well, yes. But if you're not sure, you can reduce them all so that they're the same number. Find the decimal equivalent. So these are independent. So that's really all you have to do. I usually just pick one row and always do the row because it's just easier. But you could do it with any row or any column. So let me show you another row. So another row would look like the probability of 2 given A is equal to the probability of 2 given B is equal, you get it. Sorry, that should be a 2. 2, it's because I don't want to do it, that's why. 2 given C is equal to the probability of 2 given D. Okay, and you can do the same thing with 3. I will not. So 3 given A, 3 given B, and hopefully you understand what the other two would be. If you don't, I just don't even know what to say. Okay, so like for this one here, it would be 24 over 72, 48 over 144, 96 over 288, and you'd have to see if those numbers are the same. They always will be. If one is in proportion, they're all in proportion. Okay, you could also do it with the columns, interestingly enough. Okay, so that means like that the columns, it's not interesting, it's interesting. Okay, A is the same. So that means that this A up here, screens, this A stays the same, and I work my way down here. So the probability of A, I don't have to do that. So the probability of A given 1, so this doesn't go away, so I just have to cross it out, is 36 over 360. There we go. Work with me, bro. Sorry, it froze up for a second. Okay, 36 over 360. So we're going this over this one. 24 over 240. And 12 over 120. Those are obviously the same. They're 1 over 10, 1 over 10, 1 over 10. So these guys are independent. So it doesn't really matter what you do. You can then do the probability of B given 1. That should be given 1. Probability of B given 2. Sorry, that should be 2, and that's a parenthesis. Okay, and then probability of B given 3. You have to do all of them, all of the elements in the, oh my lord. See, when I think I'm overdoing it, it just doesn't work. And you can do it with C and D It doesn't matter. So it's totally up to you what you do, as long as you do the entire row or the entire column. So let's just do an example here. Are the rows and columns independent? So what we have to do, pick a row, pick a column. Doesn't really matter. I'm going to pick this row because that's what I always do. I have issues. Okay, so I'm going to do the probability that the iPhone, whatever. They're like so similar. It's tough for me to. So the iPhone given iPad is equal to the probability of iPhone. It's hard to write for some reason, given no iPad. Okay, so iPhone is 124 over 186. And no iPad would be 108 over 162. Figure out what those numbers are. Okay, so if you reduce these or put them in your calculator, whatever, both of these are 2 over 3. So they are independent. Okay, last one here that we'll try out is this one. Hopefully it's blatantly obvious that it's not independent. You just have to go and prove it. Probability that they had disease and they tested positive, that's equal to the probability that they had a disease given that they tested negative. It's very poignant in today's society, I guess. Okay. But again, you could have done it anyway. I'm just choosing to do the one with the 997 and the 3 because it seems like it would be obvious that it's not. And then 3, remember it's this one over this one, this one over this one. I like doing it this way because it's like the fractions are written for me. Some people like to do these two, like the bottom ones, because they're literally written for you. If it's not obvious to you, you can put this in your calculator, but these are dependent or not independent. Okay? So I hope you understand. Have a wonderful day.